Alright, welcome everyone on today's lesson over parallelograms. So a parallelogram is essentially a quadrilateral, which means the figure has four sides. So it's a quadrilateral with two pairs of parallel sides. Alright, so here is an example of a parallelogram, and we call it a parallelogram because this is a quadrilateral with two pairs of parallel sides. So this side and this side are parallel, and this side are parallel to each other. Okay, so here we go. We have some properties of parallelograms. So if a quadrilateral is a parallelogram, then its opposite sides are congruent. So here's an example. If we have parallelogram JKLM, then we can say that line segment JK is congruent to line segment ML. So line segment JK is congruent to line segment ML. And line segment JM is congruent to line segment KL. Okay, so remember, if a quadrilateral is a parallelogram, then its opposite sides are congruent. So top, bottom are congruent, left, right are congruent. Here we go. Here's our next one. If a quadrilateral is a parallelogram, then its opposite angles are congruent. So if JKLM is a parallelogram, then we can say that angle J and angle L are congruent, and angle M and angle K are congruent. So opposite angles are congruent if you have a parallelogram. Next, if a quadrilateral is a parallelogram, then its consecutive angles are supplementary. So if this figure is a parallelogram, then the consecutive angles, which just means next to. So angle J and angle K are next to each other. So therefore, x plus y is equal to 180, right? They add up to 180. We can also say the same thing for angles K and L. Y plus x, they add up to 180. They're next to each other. And same thing for M and L and J and M. So the takeaway is consecutive angles are supplementary. So x plus y equals 180. I'm going to just write one example here. So the measure of angle J plus the measure of angle K, since they are next to each other, is equal to 180. So super important that you have that idea. Last property for now. If a quadrilateral is a parallelogram and one angle is right, then all other angles are right. So here is a parallelogram and it has one right angle shown. So you can assume that angle K, angle M, and angle L are also right angles. So if JKLM is a parallelogram and angle J is right, then angle K, angle L, angle M are right angles. Okay? All right, so we're going to look at this example involving basketball using these properties here. So it says in parallelogram ABCD, so this notation here means parallelogram. Suppose that the measure of angle A is 55 degrees, the measure of AB is 2.5 feet, and the measure of BC is 1 foot. You're asked to find each measure. So I'm going to go ahead and label. We know that the measure of angle A is 55 degrees, and the measure of AB is 2.5 feet. And the measure of BC is 1 foot. We're going to find DC, measure angle B, and the measure of angle C. Okay? So what I'm going to do is real quickly list out the properties. So the opposite sides are congruent. That's our first property. The opposite angles are congruent. What else? the consecutive angles are supplementary, and if one angle is right, then the other angles are right. But I'm not going to write that down. We don't need that for this problem. So let's find the measure of DC. Okay, so we know the measure of AB is 2.5 feet. Therefore, the measure of DC is 2.5 feet. Because remember, opposite sides are congruent. The measure of angle B. Okay, so I know that this is the measure of angle A. It's 55 degrees. So what is the measure of angle B? Well, if you remember, the consecutive angles are supplementary. So what I can do is, since this is a parallelogram and the consecutive angles are supplementary, I can do the measure of angle A plus the measure of angle B equal to 180. We know that the measure of angle A is 55. I need to figure out the measure of angle B. So if I subtract both sides by 55, the measure of angle B must be 125 degrees. Let's find the measure of angle C. I know measure of angle A is 55 degrees, so the measure of angle C is also 55 degrees, because remember, opposite angles are congruent. Okay? Moving on to the diagonals of parallelograms. So, if a quadrilateral is a parallelogram, then its diagonals bisect each other. So if ABCD is a parallelogram, then we can say that line segment AP is congruent to line segment PC. And line segment BP is congruent to line segment PD. Okay? So I want to go back to this. So if a quadrilateral is a parallelogram, then its diagonals bisect each other. So if the diagonals bisect each other, then it creates a midpoint. It creates a midpoint for line segment AC and line segment DB. So what a midpoint does, it splits the segment into two congruent parts for AC and also DB. So here's my midpoint. Therefore, this part is equal to that part. Here's my midpoint. Therefore, this part is equal to that part. So, there you go. All right. Next property. So if a quadrilateral is a parallelogram, then each diagonal separates the parallelogram into two congruent triangles. So if ABCD is a parallelogram, then the triangle ABD is congruent to triangle CDB. All right. Okay. Here we go. Let's look at this example. So if QRST is a parallelogram, okay, so we can assume this figure is a parallelogram, therefore I can use these properties as well. All right. So again, opposite sides are congruent, opposite angles are congruent, the consecutive angles are supplementary, and if one angle is right, then all the other angles are right. And we can also use these properties too. So if QRST is a parallelogram, find the value of the indicated variable. Okay, so I'm just going to label things that I know before I figure out the values. So we know that the opposite sides are parallel. All right, because it's a parallelogram. So opposite sides are parallel. The opposite sides are congruent. The consecutive angles are supplementary. What else? The diagonals. So here's my first diagonal, and this is my second diagonal. They bisect each other at a midpoint, which means I can split line segment TR into two congruent parts. Okay, so I use one tick mark, two tick marks, got to use 3 tick marks. But don't forget, this is the midpoints for line segment QS. So these parts must be equal to each other. Therefore, I need to draw 4 tick marks here and also there, okay? All right, what else do we have? I think that's pretty much it. So let's go ahead and find the value of x, okay? So where's x located? It is right here. Okay, so it is QT, and opposite to that is RS. So if you remember, the opposite sides are congruent, or the opposite sides are equal to each other. So I will just set 5x equal to 27. And if I divide both sides by 5, it's 5.4. But if you wanted to leave this as a fraction, you can just say x equals 27 over 5. It does not matter to me. Okay? Let's find the value of y. Okay, so here's 2y minus 5. That's the variable that I'm looking for, right? And, okay, look at that. It's on the same diagonal with y plus 4. So 2y minus 5 and y plus 4, this has 3 tick marks, this has 3 tick marks, okay? So therefore, they must be equal to each other. That's because of that midpoint, which splits the segment into 2 congruent parts. So I will subtract both sides by y, and I'll add both sides by 5. Y is equal to 9. Okay? Let's find z. Okay, so where's z located? Z is right here, so 3z. And 3z is part of this angle, right? It's part of angle PST. But if we look very, very closely, I can do something like this. And hopefully you remember back in Unit 4 that if you have a regular z or a backward z, you think alternate interior angles. Okay, because remember, these 2 segments are parallel to each other, and this is the transversal, so therefore the alternate interior angles are congruent. So 3z and 33 are congruent to each other. All right, and then z must be 11. So z is equal to 11. And one thing that I forgot to mention about this parallelogram, the opposite angles are congruent. So angle Q must be congruent to angle S, angle T must be congruent to angle R. Now this here, that 3z, that's not the whole angle S. It's actually angle PST, right? Angle S would be this whole thing. So if this is 3z, then you would equal that to whatever measure of angle Q is, okay? But that 3z would be this angle, and I'm going to match that with this 33 here. All right? Okay, moving on. We got some more stuff to talk about. Okay, so we're going to look at the back side of the notes. These are the conditions for parallelograms. Now, the conditions for parallelograms are basically the converse theorems of whatever we talked about on the front side of the notes. Okay, so we're looking at theorem 6.2. So if both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. So basically, we're trying to find the conditions and meet those conditions to see if they fit the criteria to be a parallelogram. Okay, so again, so if both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. So here's an example. If line segment AB is congruent to line segment DC, and line segment AD is congruent to line segment BC, then this figure is a parallelogram. And how we can verify these things on a coordinate plane is by using the distance formula. Hopefully you remember what the distance formula is. If you don't remember what that is, I highly recommend that you go back to your notes. So please make sure that you're reviewing Unit 2, okay? Okay, so moving on to Theorem 6.3. If both pairs of opposite angles of a quadrilateral are congruent, then the quadrilateral is a parallelogram. So here's an example. If angle A is congruent to angle C, and at the same time angle B is congruent to angle D, then this figure here is a parallelogram, okay? All right, Theorem 6.4. If the diagonals of a quadrilateral bisect each other, then the quadrilateral is a parallelogram. So here's an example. If line segment AC bisects line segment DB, and line segment DB bisects line segment AC, then this figure is a parallelogram. So how do we know if these two line segments bisect each other? Well, remember, if you have something that bisects another thing, it creates a midpoint. So this midpoint here is going to help us know if these two segments are getting bisected. And how do we figure that out? So on a coordinate plane, if you have the points, then we can use the midpoint formula to figure that out. So midpoint formula, all right? Theorem 6.5. If one pair of opposite sides of a quadrilateral is both parallel and congruent, then the quadrilateral is a parallelogram. So if line segment AB is parallel to line segment DC, and line segment AB is congruent to line segment DC, then ABCD is a parallelogram, okay? So if these two sides have the same slopes and they are congruent to each other, boom, it's a parallelogram. And we can verify this by using the slope and the distance formulas. All right, slope and distance formulas. Okay, so here's the definition. If a quadrilateral has opposite sides parallel, then it is a parallelogram by definition. So if line segment AB is parallel to line segment DC and line segment AD is parallel to line segment BC, then ABC is a parallelogram. You can just use the slope formula to verify if they are parallel. Okay, so example 3. It says verify that the points F, which is -2, 4, G, 3, 5, H, 2, -3, and J, -3, -4, form a parallelogram by A, verifying that the opposite sides have equal slopes, or verifying that the two diagonals have the same midpoint. Okay, so hopefully we all know how to plot points on a graph. So in this quadrant, we know that the X and Y values are both positive. In this quadrant, we know that the X values are negative and the Y values are positive. In this quadrant, both the X and the Y values are negative. And lastly, this quadrant here, the X's are positive and the Y values are negative. All right? So let's plot where -2, 4 is. Imagine that there is an X and Y plane on this paper here. So -2, 4 would be in this quadrant. So I'll just go ahead and plot point F there. G is 3, 5. So X and Y are positive, so it's going to be in this quadrant. So it's going to be right next to F. 2, -3. So positive, negative, positive, negative. So it's going to be under G. So point H is under G. And lastly, we got -3, -4, which is below F and to the left of H. So that's point J. So here is my quadrilateral. And what we're trying to do here, okay, so the first thing that we need to do is verify that the opposite sides have equal slopes. So we know that the top and the bottom parts are what I'm trying to look for, okay? So how do I know what the slope of FG is and also the slope of JH? Okay, so first off, the slope of FG, here's F, here's G. Remember the slope formula is y2 minus y1 over x2 minus x1, okay? So 5 minus 4 over 3 minus negative 2. 5 minus 4 is 1, 3 minus negative 2 is 5. So the slope of FG is 1 over 5. Now we need to find the slope of JH. So slope of JH, here's J, here's H, so it's negative 4 minus negative 3 over negative 3 minus 2. Negative 4 minus negative 3, that is negative 1, negative 3 minus 2, that's negative 5. The negatives cancel, so it's 1/5. Okay, so it seems like the top and the bottom are parallel to each other. Now, what I need to do is check to see if the slopes of these two sides are the same. So, starting with the slope of F, sorry, that should be J. Slope of FJ. Here's F, here's J. I'll do negative 4 minus 4 over negative 3 minus negative 2. Negative 4 minus 4 is negative 8. Negative 3 minus negative 2 is negative 1. So the slope of FJ is 8. Now the goal here is hopefully that the slope of GH is the same as FJ. So slope of GH equals, where's G? G, and then H, negative 3 minus 5 over 2 minus 3. Negative 3 minus 5 is negative 8. 2 minus 3 is negative 1. The negatives cancel, so it's 8 over 1, or 8. Great. They have the same slopes. Okay? So, therefore, A does work. Okay? So, if a quadrilateral has opposite sides parallel, then it is a parallelogram by definition. Okay, so yes, me verifying the opposite sides have equal slopes shows that this figure here is a parallelogram. Okay, so that's one way to verify if it's a parallelogram. So I'll say, therefore, FGHJ is a parallelogram. All right, therefore FGHJ is a parallelogram. Now, we can stop there, or we can show by verifying that the two diagonals have the same midpoint. Okay, so if I have this figure over here, we're basically trying to see if the diagonals bisect each other at a midpoint. All right, so how do we do that? We use the midpoint formula. So I need to look at F and H. So here's F and here's H. Let me go ahead and do this. So the midpoint of FH is equal to, so again, here's F, here's H. If you remember, we add the x's together and then divide by 2. And then we're going to add the y's together. So that's 4 plus negative 3 or 4 minus 3. And then you divide that by 2. So negative 2 plus 2 is 0. 0 over 2 is 0. So 4 minus 3 is 1 divided by 2. And that is the midpoint of FH. To find the midpoint of GJ, here's G, here's J. So I'm going to add these two x's. So 3 plus negative 3, or 3 minus 3, all over 2. I have 5 plus -4, or 5 minus 4, all over 2. 3 minus 3 is 0. 0 divided by 2 is 0. 5 minus 4 is 1. 1 divided by 2. We'll just keep it as 1/2, okay? So look at that. The midpoint of FH is the same as the midpoint of GJ. So if the diagonals of a quadrilateral bisect each other, then the quadrilateral is a parallelogram. So yes, you can say yes, parallelogram. Okay, so these are two ways to show that this figure is a parallelogram. Sometimes you might have to use the distance formula to show if both pairs of opposite sides of the quadrilateral are congruent. So I want to make sure that you're aware of that possibility of using the distance formula, okay? All right, so moving on to example number 4. It says determine whether the quadrilateral is a parallelogram, justify your answer. So I'm looking at A right now, and I notice that the top and the bottom are congruent. So line segment FG is congruent to line segment JH. Now, can we assume that these two sides are congruent? No, because it didn't state what the measure of this thing here is and also this thing, right? So it can't be theorem 6.2. Theorem 6.2 states that if both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. So the only thing that I wrote for now is that line segment FG and line segment JH are congruent to each other. Now, I notice this. I know there's 100 degrees for angle G and 80 degrees for angle H. Now, this is going to be a little difficult because you have to go back to unit 4. Now, if you remember, if two lines are cut by a transversal and the same side interior angles are supplementary, then we can say that these two lines are parallel. That's just me using the same side interior angles converse, okay? So I'm going to say that line segment FG is parallel to line segment JH by the same side interior angles converse, because these two angles do add up to 180 degrees. Okay, so if one pair of opposite sides of a quadrilateral is both parallel and congruent, then this figure is a parallelogram. So this is me using theorem 6.5. Okay, so theorem 6.5. So yes, parallelogram. All right, looking at B. Okay, so here's my quadrilateral. These two sides are congruent. These two sides are congruent. So both pairs of opposite sides of this quadrilateral are congruent. Theorem 6.2 states that this quadrilateral is a parallelogram. So all right. Okay, so moving on to example number 5. It says find each x and y value that would make the quadrilateral a parallelogram. So here's my quadrilateral, and we have 3 expressions. In order for me to find x and y, I would have to use my properties. One property that I can use, since these two angles are opposite to each other, I can use theorem 6.3. So if both pairs of opposite angles of a quadrilateral are congruent, then the quadrilateral is a parallelogram. Meaning, okay, let's equal to each other. So 2x plus 2y equals 4y plus x. I'm going to subtract both sides by 2y. So I get 2x equals 2y plus x, and then I'll subtract both sides by x here, and I get x is equal to 2y. All right. Ooh, x is equal to 2y. I have a variable equals twice another variable. This is not it, right? So let's try something else. So let's try these two angles. We know that these two angles are supplementary to each other, right? Consecutive angles are supplementary, meaning that I'm going to take these two angles and set them equal to 180. So I have x plus x, that's 2x, and then y plus 4y, that's 5y, equals 180. Now, here's what I have currently. I have x equals 2y, and 2x plus 5y equals 180. Now, if you remember back in Algebra 1, you had to do something called system of equations, specifically using substitution. So if I know that x is 2y, I can replace this x with 2y. So 2 times 2y plus 5y equals 180. And that will give me 4y plus 5y equals 180. And I'll combine the two terms. I get 9y equals 180, so y is equal to 20. So the y value for this quadrilateral is 20, but we also need to figure out what the x is. Since x is equal to 2y, we can replace the y with 20. So x equals 2 times 20 gets you 40. All right. For B, remember back in Theorem 6.2, if both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. So we can set the opposite sides equal to each other. So let's start with the top and the bottom. All right, so now let's subtract both sides by 2y. And I'll add both sides by 9. So y must equal 17. And then for the left and the right sides, we'll set them equal to each other. And then we get 6 equals 2x. So 3 equals x. Okay? Alrighty.